Okay, we're into week 6. In week 6, our main focus is going to be artificial intelligence. Artificial intelligence, more likely known by its abbreviation AI, has roots in a number of disciplines like philosophy, math, mathematics, cognitive science, neuroscience, linguistics. It's been something that has been fascinating to human beings uh, since long before the computer age, actually. It begins with an article in its most modern context. In 1950, Alan Turing, who is probably most famous as the Nazi code breaker, he broke the Nazi code. He was a British mathematician, physicist, uh, just a genius, and he was very into this fascinating subject very early. Early research began with kind of game playing things, people developing machines. You're probably all familiar with the Deep Blue machine that finally, after a number of years, was able to beat the world's best chess champion, Gary Kasparov, for the first time. Uh, Early research was applied to the idea of using computers to deduce, the idea of deductive logic. Uh, so that was basically uh, an idea that has since fallen out of fashion. Logic seems too rigid a formalism to accommodate many aspects of common sense reasoning. And I see I have a typo here. Oh well, on we go. The golden years were really 19. There were several golden year periods. The first was uh, the time between the mid 50s and the mid 70s. This is when people were reading Turing's articles and uh, articles by other people and developing not only the hardware but software. And we're going to talk about a couple of those developments here in a second. Uh, so I will. The key thing is point number 3 down there. Lisp by John McCarthy from MIT was an early AI programming language. I don't want to really even say application. It was a program that was enabled query response sorts of situations. Uh, there was a lot of funding initially in the U.S. and UK early on. Uh, there was a notion that, uh, and I think Turing had this notion very early on, machines will be capable within 20 years of doing what a human being can do. This had not so much import for people wondering about reading and writing, but the main interest I think back then was in robotics, making machines that could do the drudgery of a lot of human work, human labor. And so that's where the notion of AI first got its, or it was one of the early drivers. One guy in 1970, Minsky, predicted that in just 3 to 8 years, that would have been 1978, that they would have a machine with the general intelligence of an average human being. Shows that not all predictions come true, right? Uh, Semantic networks are networks which represent semantic relationships. It's kind of the idea that you put two things together uh, from a practical or not a data standpoint, but a logical way to start to build routines and programs and algorithms. Uh, so that's kind of the uh, broad overview of the what semantic networks are all about. Here again, Lisp was the programming. As I wanted, I don't want. I hesitate to use the word application, uh, but these were developed in the late 50s and continually developed up through I think the 70s or 80s. It's still in use, but I think on a limited basis. Fortran is another language, computer language that doesn't have anything to do with AI, but it's an old language which still has application in some areas. Don't ask me to explain what they are. uh, AI problems. So we've had golden years and ungolden years, ups and downs in the whole development and march forward of artificial intelligence. Limited computing power. Obviously, we all know the story about how the iPhones and the galaxies that we have in our pockets have more computing processing than was used to send Apollo 11 to the moon. Well, that was a key hindrance to the notion of artificial intelligence. Human intelligence had to first develop the capability to create the machines that would make artificial intelligence practicable. So there was kind of a slowdown in investment and development, and you can see here. I'll let you guys read the slides in detail as you wish, but uh, the third point was one of the hindrance was common sense knowledge and reasoning. Things like vision and natural language are kind of human resources that are kind of germane to humanity. The idea that you can put all of that into a program and marshal it via a system of bits and bytes is kind of beyond anyone's uh, comprehension. Critiques came obviously from, I have it here as a cross campus. In academia, there was been widespread debate, and there is today still, the nature of artificial intelligence. Is it even moral? You know, the philosophy majors would say, you know, is it good to replace human beings with machines? Are we all doomed if we do that? And we've all seen that, you know, it's kind of a fascinating subject for pop culture. Has been since the very beginning, you know, of time, really. I mean, in the you know, in the Wizard of Oz, they have the talking Tin Man, the famous cartoon series from the 1960s. The Jetsons kind of painted uh, a futuristic picture of the world. They all lived up kind of in a space-like atmosphere, and houses that floated in the sky or were on huge stilts, and they flew around in little space cars, and they had a robot named Rosie. She was their maid, so she replaced the human being, and so that was just one example. Rosie the maid from the Jetsons. Uh, AI had another boom in the 80s, as you see here. And that was kind of the result of a lot of investment, not just from the U.S. but from Japan and other regions of the world, Japan, Asia, and they've really gotten to be quite formal or formidable in the AI realm in Japan. But then again, there were problems. The Lisp machine market collapsed. That was due in part to the fact that personal computers were becoming as powerful at a practical level as big, expensive systems. So you were getting to the point where you have the processing power of a phone equal to what could send a rocket to the moon back in the 60s. So that made some of these systems, which required huge funding investments, and the companies behind them that were employing all the thinkers had financial difficulties, which kind of led to a brief collapse. Things began to turn around again, though, in the mid 90s, and it's still a field, artificial intelligence, that's being pursued very aggressively. Uh, we see it all the time, and we encounter it all the time. We know about the phone systems, don't we, where we call in and we answer questions that are given to us by what we know is not a human being. He or she might sound sort of human-like, but they'll ask for your account number. You'll read the account number. They'll repeat the account number back to you. Then you'll be connected to something else. That's all an example of artificial intelligence, machine learning, that sort of thing. So uh, being able to tell your Alexa something and having her respond. You ask her what the weather is, she gets it for you. Again, artificial intelligence. And we know from Alexa and Siri and some of the other things that are happening it's advancing quite rapidly now. So you could say that in our time and space here in 2019. We are in another AI golden age. There's a lot of talk of right now of automobiles, right? Self-driving cars. I don't know about you guys, but I wouldn't get in one quite yet. But that's all going to be based on AI. So the nature of intelligence is basically broken down three ways here. And this is intelligence kind of from a human standpoint, but intelligence in general. Segment one is totally known intelligence. In other words, methods exist for all problems in a field. Solutions are method-oriented. Underlying patterns can be ignored. You find the square root of a number, and it's the square root of a number. It's like 2 plus 2 is always going to be 4. The square root of 9 is always going to be, 3? So, math is a good demonstration of one area where we know what we know, and it's not going to change a lot unless another Einstein comes along and takes us into entirely new realms, which is entirely possible, I suppose. The totally unknown. These are things that human beings we're still not sure of, right? Like the search for life on other planets. How did the universe start? There's the Big Bang Theory, but there are several others as well. So we're not going to know that. I'm always intrigued when I hear people say that the temperatures on Earth today are 9 degrees hotter or 9 degrees colder than they were, a million years ago. I mean, how does anyone know? But then there's the partially known. We have a lot of areas where we're making progress, but we don't know yet. I mean, we're making huge strides in cancer research and treatment of other diseases and illnesses. Yet, new diseases emerge that we're powerless to stop. So, that's a partially known. Intelligence is required to handle the problems in segment 2, which is the partially known, or the unknown rather, and as well as segment 3. As more knowledge is acquired, topics in segment 3 move to segment 2, and topics in segment 2 move to segment 1. So the smarter we get, the more things get pushed up from the totally unknown to the totally known. So look at kind of as maybe a pyramid would have been a good way to kind of diagram that. So Alan Turing had this notion of the Turing test. A machine can be described as a thinking machine if, in two isolated dialogues, one with a computer and one with another human being, the human agent can't reliably identify which dialogue is with the computer. So I think I know of an example of this. I am not positive, and I guess I should research a little more, but sometimes I don't know how many people pay their bills online or even go to a site where they have an account just for questions like, is my phone eligible for upgrade? You start your AT&T screen, and up pops a little dialog box automatically that says, "Hello, my name is Jessica. How may I help you today?" Usually what I do is I click the little X and Jessica goes away. Or, or Darren or Louise, whoever. I think they changed the name, but I really don't believe that there's somebody waiting at her computer at IBM to type me a message as soon as she sees that I sign on. And frequently, whoever the dialogue is will pop up. Anyway, so on rare occasions, I have actually queried these folks, and they do respond. And I don't know if it's a combination of human interaction or it might be a hybrid. But so it's getting close to the I don't know that I'm not whether I'm talking to a human or a computer. So that's the easiest example I can think of. Obviously, when we do the phone calls, we know we're talking with a machine just by the way they talk, or Um, we have a pretty good hunch. But over time, I think it'll become more and more human-like, and we won't know. So that's where things are headed. Uh, Artificial intelligence is basically currently based on, and one of the reasons why I selected the screen background for all the slides you guys have had to look at here, is that it reminded me of diagramming an advanced neural network, which you'll see the next slide. Artificial intelligence is basically all search. It's all based on computers anticipating our actions based on what we doing, what's our input. We all know about entering something in the Google window, right? And it starts to fill out what we might be searching for, and it'll go all the way with you until you put a complete sentence in the Google query window. But a couple things come into play: problem space, game theory. Every problem is a space of successful or unsuccessful queries and solutions. So the trick is to find the most efficient strategy. Here's the kind of a visual representation. I think this is fake, of the machine playing chess against Garry Kasparov, or that's, I think, what it's supposed to indicate. We all know the story of the computer that beat the chess champion. So learning is all about a couple of different things. This is represented in two ways in terms of input layers, hidden layer 1, hidden layer 2, and output layers. So, which is diagrammed in a different way up at the top right. Here, that's probably the best way to describe it. There's a query. My tier production is poor, or my tier production is normal, and I have some kind of eye problem. Well, you could either go from you have astigmatism or you don't have astigmatism. So there are a couple different ways that can branch. Or you are not astigmatic. And you see the way the question gets played out here, and ultimately by a series of choices, which advanced neural network always branch from a question or a query out to usually two different places, or three, but very simple as it looks in the bottom left window. So ultimately you get from a question to an answer. So and as I say, that's the way, when you think about it, a lot of things that we encounter as having artificial intelligence work. So Watson is a big IBM project, an initiative that's gone on for a number of years, and the goal behind Watson was to have computers interact in normal human terms across a range of things. Basically, giving machines the ability to even learn, even develop, train themselves to learn. That's why we hear that Alexa and Siri learn our voices gradually, learn our pronunciation if they don't understand us. All of that is kind of a logarithmic training process. IBM describes the Watson AI as an application of advanced natural language processing, information retrieval, knowledge representation, and reasoning, and machine learnings, and applying all these to the field of open domain question answering. And there's Rosie from the Jetsons. She could always, she was actually smarter than George Jetson, I think, who was the main protagonist of the show. This is another schematic that basically runs through the question and answering process. There are some overlying things. You get answer sources, evidence sources, model training, which is developing logarithms around uh, interaction. Those are all sort of outside the diagram here, but all part of the resources that go into the process you see here. From question analysis, breaking the question down, uh, generating possible outcomes, that's hypothesis. There are filters, scoring evidence, the possibility of right and wrong, and all this kind of stuff goes into what we, as I mentioned, Google a little bit back, into what happens as we make a query to Google. So remember, AI is search. A lot of AI is all about searching. You come to many, 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 many forks in the process of a single question sometimes. And, the power of the computers are so great now that, it's almost uh, completely transparent to us human beings how much really happens, and really kind of what a miracle it is when you look back at the last 50 years or so, how things have changed so much. Uh, well, so here are some of the specifics of I'm not going to read through these, but you can if you want to, of the original Watson project, and how Watson works. As I say, this kind of reiterates some of what I just said. Uh, Search for statistically related phrases, uh, quick execution of language analysis algorithms. All that's very important. So I guess for our last slide, we're going to go back to the whole notion of robotics, which is, as I say, was a key consideration in the early development of AI. And here are some of the AI top robot countries in the world. Notice we're not really that high in the US. Uh, and notice how high Japan is. Japan was an early investor, early believer in AI. Same with other Asian countries like Singapore, South Korea. So there's room for growth in the area here in the U.S. Even though a lot of the technology, the underlying technology, a lot of it, most of it even, came from U.S. Resources in business and education, MIT, places like that. Uh, so, but the application of robotics isn't as great. Now, robots are. How do you define a robot nowadays? It's said that all our phones have robotics built into them. The things that know to wake our screen up when we move. So that's an application of robotics. So this may be a 5 or 10 year old graphic too. I should look into that. So we might have caught up through application of robotics just in that. I'm thinking of buying a Roomba, which is a sweeping vacuuming robot for our wood floors. I'm just worried about dog hair clogging it up. That would be another application of robotics.